Question 1. Expand and simplify. A method is using the term FOIL, so first terms, then inside terms, outside terms, and last terms. Multiplying each of those together, collecting like terms to give you x squared plus 4x minus 21. For question 2, in order to calculate the mass of the prism, we need to use the formula mass equals density times volume. Now the volume of the prism can be calculated by calculating the area of the cross-section, which is actually a trapezium, the formula for which can be found on the formula sheet. It's the half the sum of the opposite sides multiplied by the distance between. This gives you the area of the cross-section multiplied by the depth, 6 centimeters, gives you the total volume of the prism. Multiply that volume by 0.7, the density, to give you 453.6 grams. The table below shows information about the length in centimeters of 40 leaves. In order to calculate the modal class, we need to look for the group with the highest frequency. Highest frequency is 14, therefore the modal class is the group where L is greater than 3, less than or equal to 4. In order to estimate the mean, we need to estimate the size of the leaves in each group. Now if we look at the first group, we don't know the size of those 4 leaves. They are somewhere between the length of 0 and 1 centimeters. So we're going to estimate that all 4 of them are 0.5 centimeters, i.e. the midpoint of that group. So we calculate the midpoints of each group, 1.5, 2.5, etc. Multiply the number of leaves in that group by the midpoint to give us our column midpoint times frequency. Sum that column, giving you 113, and divide that by the total frequency. Often this is told for you in the question, 40 leaves. 113 divided by 40 to one decimal place is 2.8. Astrid plays a game of chess against her computer. She will either win, draw or lose, hence why I've created the tree diagram with those 3 options: win, draw, lose. Now the probability she will win is 0.3. Probability she will lose is 3 times the probability that she will draw. So if I call the probability of her drawing x, well, the probability of her losing is 3 times that probability, i.e. 3x. Now we know that these are the only 3 outcomes, either a win, a draw, or a loss. Therefore, the total of those probabilities must sum to 1. 1 must equal 0.3 plus x plus 3x. Taking away 0.3 from both sides, 0.7 must equal 4x, so x must equal 0.175. This is the probability that Astrid will draw. The probability she will lose is 3 times that amount, so 0.525. When approaching a trigonometry question with a right-angled triangle, I suggest the first thing you do is label the sides. Then circle the the one that you know and the one that you want to find out. In this case, you know the adjacent, you want to find the hypotenuse, the length AH. The formula that links adjacent and hypotenuse, so SOHCAHTOA, is cosine. So we can write down that cosine 22, which equals the adjacent over the hypotenuse, so 14.9 over h. Rearranging this, so multiply by the h, divide by the cosine 22. The in-between step there is h times cosine 22 equals 14.9. Dividing them by cosine 22, which gives you 16.1 to 3 significant figures. In order to work out the percentage increase in Donald's pay, we need to look for the difference between the pay divided by the original pay times 100. So the difference between the pay, £668.80 minus £640 divided by what he got in 2014, say £640 times by 100, 4.5%. Now to work out Donald's weekly pay in 2016, well, if we think about the sentence carefully, so in 2015 Donald's weekly pay was 95% of his weekly pay in 2016, i.e. his 2016 pay times by 95%, which as a decimal is 0.95, equals his 2015 pay. Now the 2015 pay we know, £668.80, and if I divide that by 0.95, that will give me my 2016 pay of $704. With ratio questions, the order is important, so Rachel, Mario and Sanjeet share money and the ratio is 4:3:9, i.e. Rachel gets 4 parts, Mario 3 parts, Sanjeet 9 parts. If Mario receives £96, well, as his is 3 parts, 96 divided by 3, 32. If I multiply 3 by 32, it gives me my £96. So if I do the same for the others, 9 times 32, 4 times 32, that will give me the amount that Rachel and Sanjeet had. 9 times 32, 288, 4 times 32, 128. We're looking for the difference between the amount. Subtract them, £160. Now in order to construct an angle bisector, you need to use a compass. First thing to do is to put your point on the point where the lines intersect and draw an arc. You now need to move your compass point to the intersection points. Now, keeping your compass the same length, draw an arc, move the points to the other intersection points, draw an arc. So here we've formed actually an isosceles triangle. In fact, this too is an isosceles triangle. If I now draw a line between the intersection point of the lines P, Q and QR and where my arcs intersect, I will have created a perfect angle bisector. In order to solve these simultaneous equations, well, we need to eliminate one of the variables. Now currently, this number in front of the x's and the y's aren't the same. So therefore we need to manipulate the equations. Now, if we consider the x variable, now both 2 and 5 go into 10. They're both factors of 10. So if I multiply the entirety of the first line by 5 and the entirety of the second line by 2, that will result in the number 10 being in front of both of the x terms. Multiplying the top line by 5 also gives me 35y and 155. The bottom line by 2 gives me minus 6y and 32. Now if I cancel these two lines, I'm trying to eliminate the x term, so 10x minus 10x is going to give me 0x. This is where you need to be careful. 35y take away minus 6y. So 35y take away minus 6y. Take away a negative, which is an addition. So therefore 35 plus 6y, which is 41y. 155 minus 32 is 123. So 41y equals 123. Divide by 41, y equals 3. At this point we can then substitute into any of the top equations at the top. I've chosen the very top initial equation. Subbing into that, say 2x plus 7 times my y value, which is 3, equals 31. Rearranging that gives me 2x equals 10. I subtract 21 from both sides. Divide by the 2, x equals. In order to calculate the value of Bintu's investment at the end of 3 years, we need to use the formula, which is the original times your multiplying factor, the power of the number of years, and this gives you the amount in the account at the end of that number of years. Well, the original amount that Bintu puts in the account is $7,500. As it is a 4% compound interest per year, so 4% increase, 100% plus 4%, 104%, which is a decimal, is 1.04, i.e. my multiplying factor is 1.04. Number of years that it's in the bank is 3. Another way to do the same question would be to think, right, I've got my original amount. I know that I am multiplying by 1.04 in order to work out the amount at the end of the first year. Then if I take that amount and again multiply by 1.04, the amount at the end of the second year, times by 1.04, gives me the amount at the end of the third year. You should see that actually I've multiplied by 1.04 3 times. This is the same as doing 7,500 times 1.04 to the power of 3. While calculating the probability that the adult's age is more than 50 years, well, the number of adults who have an age of greater than 50 are 16 plus 8 plus 4, which gives me 28, so 28 adults, out of a total of 90 adults, i.e. probability-wise, 28 out of 90, or equivalent. Cumulative frequency, well, that's summing the frequency columns I go down. So, first term 4, 32 is 4 plus 28, 62, well, that's the previous amount, 32 plus the new frequency 30, etc. You can check that you've got your solution correct by your final value should be the same as the total frequency, 90 adults. When plotting the data on a cumulative frequency graph, the key is to remember to plot the cumulative frequency at the top of the data range. So the group 20 to 30, I need to plot the point 4 at the point 30, plot the point 32 at the point 40, plot the point 62 at age 50, plot the point 78 at age 60, etc. Then when using the graph to calculate an estimate for the number of adults who receive a discount, well, we're saying greater than 65 years receive a discount. So draw a line up to your graph from 65 and across to the cumulative frequency axis. On my graph this comes to a value of 82 and we want the number greater than 65 years of age. So those over 65 receive the discount. So out of our total frequency of 90, take away those below the age of 65, of which there are 82 results. So 90 minus 82, which leaves you with 8. And according to the mark scheme, you should have your value somewhere in the range 6 to 8. Okay, when converting a decimal number into a standard form, so the key to standard form is remembering we need one number before the decimal point. So in this case we know our result is going to be something to do with 4.51. In standard form we have times 10 to the power of something, and that power tells us how many times I've moved the decimal point. So in our example, we have moved the decimal point once, twice, 3 times, 4 times. And if I had a positive power, that would suggest I had a large number to start with. A negative power is for a decimal value. Negative power, so actually what you're doing here is you're dividing by 10 to the power of 4 rather than timesing by 10 to the power of 4. When calculating the result of 7.8 times 10 to the 5 divided by 2.4 times 10 to the minus 4, you can think about both of these sections independent from one another. So 7.8 divided by 2.4 is 3.25. That can be done on the calculator. 10 to the 5 divided by 10 to the minus 4. So in division, I subtract the powers. 5, take away minus 4, i.e. plus, giving me a result of a value of 9. Therefore my solution in standard form is 3.25 times 10 to the 9. When expanding and simplifying these brackets, the obvious thing to note to start with is that if I expand x minus 3, x plus 3, actually that expansion is going to leave me with just two values. The minus 3x and the plus 3x will cancel out. As you can see what I've done in my expansion here. So we get x squared plus 3x minus 3x minus 3 times 3 minus 9. Okay, I've left the first bracket by itself, and I'm going to consider that later. Simplifying the expansion gives me x squared minus 9, and so when expanding x plus 5 and x squared minus 9, I'm going to get x cubed minus 9x plus 5x squared minus 45. If the cups are mathematically similar, that means the sides are in the same ratio, the areas are in the same ratio, the volumes are in the same ratio. So in order to calculate the ratio between the cups, I need to think about, so going from A to B, well, from the side of 12 centimeters, I need to times by some factor to get me to my side of 8 centimeters. Well, this factor I'm going to times by, well, I like to think of it as, I need to cancel the 12 out, I need to end up with a result of 8, i.e. timesing by 8 over 12, and that would cancel the 12, and leave me with the value of 8. So my factor here is 8 over 12. That's my scale factor, my length scale factor, going from A to B. To go the other way around, actually, is the inverse of that scale factor, i.e. timesing by 12 over 8. For part A, we want to work out the value of D. Well, I'm going from the larger cup to the smaller cup, so therefore timesing by a fraction less than 1, timesing by 8 over 12, which gives me a value 6. And part B, we're told the volume of the smaller cup. I know my length scale factor to go from B this time to A. Well, I'm increasing in size, I am multiplying by a value greater than 1. My scale factor, as we worked out before, we said is going to be 12 over 8, so my length scale factor 12 over 8. My area scale factor is my length scale factor squared, so 12 over 8 squared, and my volume scale factor would be my length scale factor cubed, so 12 over 8 cubed. Now we're considering volume in this question. I want to work out the volume of A. So I take the volume of B, which is 160, and I times by my volume scale factor. So timesing by 12 over 8 cubed. Typing this into your calculator gives you a result of 540 millilitres. Two solid plates P and Q are mathematically similar and made of the same material. Those are key words, mathematically similar and same material. Same material results in the conclusion that they're actually of the same density. The same density. Now if I think of my formula on my density equals my mass divided by my volume. The rearrangement of this is that my volume times my density equals my mass. Now for our two plates, the density is the same. Therefore, the volume for both discs is proportional to the disc's mass. The constant in proportionality in this case is my density is the same, so therefore my volume is proportional to my mass. I'm going to come back to that formula in a minute. If we think about our two solid plates P and Q, well, the surface area of P equals P centimeters cubed, so the surface area of Q is Q centimeters, squared surface area. Now, we also know the weight of P, which equals W grams. That should actually be mass in the question, but never mind. And we want to find the weight of Q. Now, if we consider the scale factor to go from P to Q in terms of surface area, I need to think that P times some fraction equals Q. I want to cancel the P's and end up with the result Q. So my scale factor is Q over P. So my scale factor here is Q over P. Now what's the scale factor for surface area? So my area scale factor is Q over P. My length scale factor, well, the length between these is to go from length to area. I'm squaring the scale factor. So to go the other way around, I need to square root. So length scale factor is the square root of Q over P. The volume scale factor is going to be the length scale factor cubed. Now we come back to the equation we came to at the beginning. I know my volume is proportional to my mass. If I want to work out mass, then I can just use my volume scale factor as they are proportional to one another. So therefore my mass or weight in this case, scale factor, let's go from W to the weight of Q is to times by volume scale factor. So the square root of Q over P all cubed. So therefore I'm taking my weight W and I'm timesing by my volume scale factor. Q over P all cubed. This is your final answer. That is the weight. Technically should read in the question mass, but weight of the solid plate Q. the square root of 8x to the power of 8, well, square root is the same as a power half. So therefore I can write root x as x to the power of half, all to the power of 8. When I've got brackets, I multiply my powers, so half times 8, which equals 4. I'm left with the solution x to the power of 4. Alternatively, root x to the power of 8 is the same as root x times by itself 8 times. Okay. We can now spot that actually root x times root x is x. So I'm left with x times x times x times x, which is the same as x to the power of 4. Solving this algebraic equation, our first step is to get rid of the fact that on the left hand side we've got to divide by 3 by timesing by 3. So times both sides by 3. This would cancel out the divide by 3 on the left hand side, and multiplying everything on the right hand side by 3 leaves you with a 15 minus 6y. Next step, I've done 2 steps in one. I have added 6y to both sides. 4y plus 6y is 10y. And I have taken away 6 from both sides. 15 minus 6 is 9. Finally, dividing by 10 gives you a value of y, 0.9. To make g the subject of the formula, I want to end up at the point g equals. That's what I'm aiming for, and I do not want the g variable anywhere else other than just by itself on one side. So first things first is I need to get all the g terms to one side. So take away gh, and at the same time let's add the 1. Adding to the 1 to both sides will cancel that minus 1. Subtracting gh will cancel that gh. I'm left with g minus gh equals 1 plus 3h. Factorising now, because I've got a common factor g. G times 1 is g, g times minus h is minus gh. So my common factor g, and then finally divide by the bracket, leaving you with g equals 1 plus 3h over 1 minus h. M is inversely proportional to g cubed. So first step, well, inverse proportion. That means that I've got 1 over as my relationship. So M is inversely proportional to 1 over g cubed. Now, if I want to make that equal, I need to add a constant of proportionality. Often we use the value k, so m equals k over g cubed. I need to work out this value k, and to do that, I'll substitute in the values that they've given me. M24, and g is 2.5. So 24 equals k over 2.5 cubed. My line in here is I'm timesing by 2.5 cubed, both sides, and if I work out the left hand side of the calculator, it gives me 375, and the k value is 375. Now I need to find the formula for m. And the formula, well, that is substituting my k value back into the original equation. So m equals my k value, 375, divided by g cubed. Part B, work out the value of g when m equals 1/9. Well, I now take my formula from part A, and I substitute in that m equals 1/9. So 1/9 equals
375 over g cubed. To get from my first line to my second line, I need to multiply by g cubed. This would cancel out g cubed on the right hand side, and the left hand side would leave me with g cubed over 9. And then to calculate the value of g, I need to times by 1/9 and then cube root. So cube root of g cubed leaves me with g, and the cube root of 3,375 is 15. Therefore, the value of g when m equals 1/9 is 15. In order to find the value of e and f, we need to initially multiply out the brackets on the left hand side and then compare my left hand side with my right hand side of this equation. Multiplying the brackets, well, I'm first going to get 5 root 2 times 3 root 2. So 5 root 2 times 3 root 2. Well, 5 times 3 is 15. Root 2 times root 2 is 2. 15 times 2, 30. Okay, so that gives me my first term. 5 root 2 times e, it leaves me with 5e root 2, minus e times 3 root 2, minus 3e root 2, and minus e times plus e, well, e times e is e squared, and we've got minus e times e, so minus e squared. I'm now going to combine my integer terms. Well, 30, I know is an integer, 5e root 2 and 3e root 2 there. Irrational, they're surd values. But e squared, that is also an integer. We're told in the question that e and f are positive integers, so therefore e squared must be a positive integer. So my minus e squared is also an integer value. So I've grouped those together. 5e root 2 minus 3e root 2 is 2e root 2. Now comparing my integer values on the left and right hand side, well, I've got, as I said before, 30 minus e squared on the left hand side, and on the right hand side minus 6. And my integer values, my irrational parts, my surd parts are 2e root 2 left hand side, f root 2 on the right hand side. So I can compare those two and say that actually, well, 30 minus e squared must be the same as minus 6. 30 minus e squared must be the same as minus 6. In order to solve that, well, I've done 2 steps in one again. I've added 6, and I've added e squared to both sides. 30 plus 6 is 36. Add the e squared, cancels off the left hand side, and brings it onto the right hand side. Next step, square root. 36 square rooted gives me plus or minus 6. Now if we compare the irrational parts, my surd values in the expressions, 2e root 2 must be the same as f root 2. So 2e root 2 must equal f root 2. Now I can cancel the root 2's from both sides, leaving me with 2e equals f. Now I know my e value. My e value is plus or minus 6. So 2 times plus 6 is 12, 2 times minus 6 is minus 12. So my f value is therefore plus or minus 12. Now if we consider the initial question, we're told that e and f are positive integers. So therefore the only results can be that e must be 6 and f 12. They are positive integers, not negative. So e equals 6, f equals 12. vectors question and we're told that p to q equals a, p to s equals b. I like to label these values on the diagram. So p to q in that direction specifically is a, opposite direction would be minus a, p to s is b. First question is to calculate q to s. Now q to s is the same as going, rather than straight from q to s, we can go via p. So q to p plus p to s. Q to p, well that's going in the opposite direction from the vector p to q. So q to p is going to be minus a. P to s, well we already know that is b, so minus a plus b is my vector q to s. Now the vector q to y, well I'm told that y is the midpoint of p to s. So therefore q to y I could write down as going from q to p, which we already know is minus a, plus p to y. P to y, well that is half of p to s. P to s is b, so therefore p to y must be half b. So I've got minus a being q to p, half b, which is p to y. So q to y minus a plus a half b. P to x, well, we can either go via s, so p to s to x, or via q, p to q to x, and these will actually give me the same vector solutions. So p to x, well that is p to s plus s to x. P to s I know is b, s to x, well we've already worked out q to s, q to s we've said is minus a plus b. So therefore s to q, the opposite direction, is actually going to be a minus b. S to x, well that is half of s to q, therefore half of a minus b. So p to x, well that is p to s, which is b, s to x, which is half of a minus b, or minus b plus a. Multiplying that out, we get minus a half b plus a half a. So I've got b minus a half b, which gives me a half b plus a half a. So p to x is a half b plus a half a. Now if we'd gone the other way, if we'd gone via q, p to q plus q to x, well p to q we know is a, q to x, well that is half of q to s. Q to x, half of q to s. So half of minus a plus b, a minus a half a, leaves me with half a plus a half b. Probably work out the coordinates of v. Well, we're told the coordinates of p, and so in order to work out the coordinates of v, we're going to consider the vector p to v. If I know the vector p to v, then I can translate my p coordinates to find my q coordinates. Sorry, v coordinates. P to v is the same as going p to r plus r to x plus x to v. The reason I've gone this direction is that I'm told p to r, and I'm also told x to v. I just need to calculate r to x. We're also told that p to r is 2/3 of p to x. So p to r, click on the diagram, this value here is 2/3 of the entire distance p to x. So we're left over with r to x must be 1/3 of the entire distance p to x. So as a ratio of the entire length p to x, p to r, that makes up 2 parts. R to x, that makes up 1 part. So I know the vector p to r is 40, that makes up 2 parts. So therefore the vector r to x, well, that's half as big. So therefore it's going to be the vector 2, 1. So my vector rx is 2, 1. Therefore the overall vector p to v, well, is 4 plus 2 minus 5, so 6 minus 5, which is 1. 2 plus 1 plus 4, 3 plus 4, which is 7. So I need to take my coordinate point 3, 1, and I need to go 1 right and 7 up from the point 3, 1. So 1 right would take me to the coordinate point 4. 7 up, well, I'm going from 1 up 7, taking me to the coordinate point 8. So the coordinates of v are 4, 8. In order to master Venn diagrams questions, it's all about understanding the notation. So here we've got two sets A and B. The number in the universal set is 50, i.e. the number in the whole group is 50. The number in A intersect B, or and B. The number in A intersect B, A and B is 4. The total number in A is 5, and the total number in B is 9. When completing a Venn diagram, you want to start from the inside and work outwards. Now we know that the number in A and B, i.e. the bit in the middle, is 4. The number in group A, this group here, is 5. Now we've put 4 down already, so we've got 1 left over. 5 minus 1, 4. The total number in B is 9. Put 4 down already, so 9 minus 4 gives me 5. I've already put down 1 plus 4 plus 5, 10 on the diagram already. I know the total in the universal set is 50. 50 minus 10 is 40. Now the number in A intersect not B, B dash meaning not B. So the number in A and B not B, then A and not in B. So it must be in A, not in B, is 1. And this one's slightly more complex. I can either be in A, this one here, maybe if I shade it, I can either be in A, or I can not be in B. So not being in B, the bits I'm adding, everything on the outside. So I can be in A, or not in B. So the bits I've shaded there are 40 plus 1 plus 4, 45. Now there are two ways to work out an inverse function. First method is to write y in place of
f of x. Then, nothing mathematical about this, just swap the x's and y's. So where I had a y, I'm going to write an x. Where I had an x, I'm going to write a y. Now I want to get to the point where I have y equals. So first off, here I've swapped these two around. Mathematical process there is I've times by y minus 3 and divided both sides by x. That gives me y minus 3 equals 4 over x. Add the 3, so y equals 4 over x plus 3. So the inverse function is 4 over x plus 3. Alternatively, you could think of it in terms of a flow diagram. So I take my input, x. I then take away 3, leaving me with x minus 3. I take that value and I raise it to the power minus 1, giving me one over x minus 3. I then take that value and times it by 4. That's how I get 4 over x minus 3. Now to work out the inverse, we're going to go in the opposite direction. So we're going to start with our value x, and rather than timesing by 4, I'm going to divide by 4. We're going to, in this case actually, to the power of minus 1, and we're going to add 3. Take my x value, divide by 4. Put to the power of minus 1. So that gives me 4 over x. The reason why these ones don't actually change is that what we're doing is we're flipping the fraction. Here I had x minus 3 over 1. I'm going to flip it to give me 1 over x minus 3. Here I've got x over 4. I'm going to flip it to give me 4 over x. So the process we're doing there is a flipping, an inversing of the fraction. Then finally, I'm going to add 3. 4 over x plus 3. The inverse function of x. Again, two methods for calculating fg of a. First, if we think about g of a, well, g of x was x minus 2 over x. I'm now substituting rather than a x value, I'm substituting in an a value. So I'm end up with a minus 2 over a. Fg of a, well, that's the same as fg of a is a minus 2 over a. So I'm doing f of a minus 2 over a. That means where I have an x in my function f of x, I'm substituting in a minus 2. Now the function f of x was 4 over x minus 3. So where I've got an x term, I'm going to replace with a minus 2 over a. Hence 4 over, there's the term I've replaced, a minus 2 over a. So 4 over a minus 2 over a minus 3. Now I want to solve where fg of a equals 1. So I'm solving 1 equals what we calculated fg of a to be. First process is to multiply by the whole of the denominator. Multiplying the right hand side by the denominator, we obviously cancel that value, leaving me with just 4. 1 times that denominator, well, 1 times anything just leaves you with that value, anything. So I'm left with a minus 2 over a minus 3, so I'm left with just the denominator parts. Next step, add 3 times by a. That would cancel out to divide by a. Rearrange to bring the a's to one side, so minus an a, and finally divide by 6, which leaves me with minus 2 over 6, the same as minus 1 over 3. Find that up. Alternatively, we can think of working out f g of a equals 1. Well, to get rid of the function f, I can inverse it. So if I apply the inverse function to both sides, well, that would cancel out the function f, leaving with g of a on the left-hand side equals now the inverse function f of 1. G of a we've calculated already over here, a minus 2 over a. F to the minus, so the inverse of the function f of 1, well, I'm substituting 1 into the inverse of f of x, which is 4 over x plus 3, so substituting 1 into that, 4 over 1 plus 3, 4 divided by 1 is 4, plus the 3 is 7, so I'm left with solving a minus 2 over a equals 7, again, times by a, then minus the a and divide by the 6, which is what we did over here, leaving me with the same value, a equals minus a third. So in order to calculate the size of the angle between VC and the plane ABCD, we have to think about what shadow the line VC causes on the plane ABCD. The plane ABCD is actually the bottom of this prism. If I was to shine a light perpendicular onto that plane, so perpendicular onto that plane, the shadow that VC casts onto the plane is going to be directly below it, i.e. perpendicular directly below the point V. On the plane is the point M. C is already on the plane. Actually, the shadow formed is going to be the line between M and C. So therefore, the angle I'm looking for is the angle between VC and the line MC. First off, we need to calculate the length of the line MC. I know the length of VM, which is 7. I needed another length on this triangle in order to work out the angle between the line and the plane. So if I think about my triangle MDC, again another right angled triangle, I know the bottom length 15, length MD, well that is half of BC, BC is 10, so MD is 5. Apply Pythagoras to that, so 5 squared plus 18 squared will equal MC squared, so MC is the square root of 5 squared plus 18 squared. Now we can add that to our diagram here, so this is the square root of 5 squared plus 18 squared. Which, again, I've drawn over here. Plus, I've labelled the sides. Opposite the angle, adjacent to the angle, longest length, hypotenuse. Circle what you know. So we know the opposite and the adjacent. The formula that links O and A, well, that is TOA. Tan theta equals opposite over adjacent. So tan theta is 7, my opposite, over root of 5 squared plus 18 squared. So that's what tan theta equals. In order to get the function tan to the other side, I need to inverse it, so tan to the minus 1, or arctan of 7 over root 5 squared plus 18 squared, which if you type in your calculator gives you 20.541. 2. 3 significant figures. is 20.5 degrees. In order to simplify this expression and so subtract the two fractions, we need to have a common denominator. Now, the first thing to do with algebraic fractions is always to factorize your denominator values. So, common factor of 2x plus 12 is 2. So the denominator of my first fraction is going to be 2 brackets x plus 6. The denominator of my second fraction, well, 6 times 8 is 48. And if 6 is positive, 8 is negative. So 6 times minus 8 minus 48, 6 plus minus 8 is minus 2, i.e. they multiply to give me the value by itself and times to give you the value in front of the x term. So therefore I can put those values into the double brackets, x plus 6, x minus 8. To double check, if I multiply that out, I'd get x squared minus 8x plus 6x minus 8x plus 6x is minus 2x. 6 times minus 8 is minus 48, so I'd have x squared minus 2x minus 48, which is what we had up here, so we factorised it correctly. The lowest common denominator, therefore, is going to be 2 brackets x plus 6, x minus 8. What we're looking for there is the lowest common multiple. Say, for example, I had two fractions where the left fraction had a denominator of 2 times 3, the right fraction had a denominator of 3 times 5. Well, yes, I could have a denominator of 2 times 3 times 3 times 5, but actually my lowest common multiple of 6 and 15 is going to be 2 times 3 times 5. So the same here. Write down the terms that are common and then include every other term. So the 2 and the x minus 8. You've now got to think about what did I multiply the denominator of my first fraction by? Well, I multiplied it by x minus 8, so I have to do the same to the top, multiply by x minus 8. If I was to cancel those, I'd be left again with 3 over 2x plus 2 brackets x plus 6. Again, the same with the other one. Well, I multiplied the denominator by the value 2. So I need to multiply the numerator by the value 2. If I was to cancel those again, I'd be left with the same as the expression above. Now, because we've got common denominators, we can, in this case, subtract the two fractions. So 3 brackets x minus 8, take away 2 brackets x minus 15, all over 2 brackets x plus 6 brackets x minus 8. At this point we can multiply out the brackets. 3 times x gives me 3x, 3 times minus 8, minus 24, minus 2 times x, so minus 2x, minus 2 times minus 15, plus 30. Combining like terms, so 3x minus 2x is x, 30 minus 24 is plus 6. So on the numerator, I have got x plus 6 over 2 brackets x plus 6, x minus 8. Now the numerator I could write as 1 times x plus 6. It's the same thing. And when we cancel the common factor, top and bottom, I'm left with 1 over 2 brackets x minus 8. That's why it's important not to multiply out your denominator too soon. If you do, you might miss a common factor in the numerator and denominator that you can cancel. As we want to leave it as simply as possible, that means to leave it in factorised form. So don't expand the bracket, therefore the result is just 1 over 2 brackets x minus 8. Arithmetic sequences series come with two formulas, one on the formula sheet, so the sum to n terms is n over 2 brackets 2a plus n minus 1 d, where my letters represent the nth term, that's the letter n. A is the first value, start value, and D is the common difference. The second formula you need to remember actually is the nth term of an arithmetic series. Arithmetic meaning a series that goes up by a common amount. And that is just a plus n minus 1 d. Which makes sense. When I'm looking for the first term, i.e. when n is 1, well 1 minus 1 is 0, so 0 times d, I'm just left with a, the first term. When I'm looking for the second term, well I'm just going to be adding on that common difference, d. So what I'm looking for is a plus d. Second term, n is 2, 2 minus 1 is 1, so I've got a plus 1 times d, or a plus d. It's an intuitive thing. Now we're told in the question the sum of the first 10 terms is 290, and the third term is 19. So if I consider the sum of the first 10 terms first, so sum to 10, so when n is 10, I've got 10 over 2, brackets 2a plus 10 minus 1d. Simplified, well, we know that the sum of the first 10 terms is 290, so 290 equals 10 over 2 is 5, 2a plus 10 minus 1d, 10 minus 1 is 9, and here what I've done is I've divided both sides by 5. 290 divided by 5 is 58. Inside the bracket is 2a plus 9d, so I'm left with an equation 58 equals 2a plus 9d. Now if we consider that the third term of the series is 19, well, the third term is 19, the first term I don't know, but I know the term number I'm looking for is the third one. So 3 minus 1, which is 2, so I know another formula, 19 equals a plus 2d. I've got actually two equations, two linear equations. We've got a linear simultaneous equation. Currently we don't have the same values in front of the a or the d, but I can manipulate one of the equations by multiplying all of the terms by, in this case, 2, so that I have the same value in front of a. I write the first equation down as already expressed. The second equation, if I multiply every term by 2, so 19 times 2 is 38, 8 times 2 is 2a, 2d times 2 is 4d. Now I've got the same value in front of a, so when I subtract one equation from the other, 58 minus 38, 20, 2a minus 2a is 0, they'll disappear, 9d minus 4d is 5d. So I'm left with one variable. I've eliminated the a terms to leave me with just an equation with one variable in. Hence I can now divide by 5 to give me d is 4. I can now substitute the d value 4 into any of the equations, so either of these two here or this one here. In actual fact, these two equations are exactly the same as each other. One is just a factor of the other. So if I substitute, I've chosen to substitute into this equation here. 19 equals my a term plus 2 times my d term. My d term is 4, so 2 times 4 is 8, minus the 8, which gives me a equals 11. Now, that is not the final solution. Final solution is to find the 10th term of the sequence. Well, we want the 10th term, i.e. when n is 10. I'm using this formula here. I know my a value, 11, my d value, which is 4, my n value, I'm looking for 10. So 11 plus 10 minus 1 times 4, 10 minus 1 is 9 times 4, plus the 11 gives me 47. So the 10th term in my sequence is 47.